you start by making a line. So make a line with your GeoGebra, okay? And then put a point somewhere above the line, just like that. Did that? Tell me if you need help. We're good? Are you doing this, Ashley? I mean, Evelyn? Come on, let's go. I want everyone to do this. All right, then we're going to construct a parallel to this line through this point. So you guys should be getting pretty good at this stuff, but you just go to parallel line, and you click on that point, and then you click on that line, and it'll make a parallel line. Did you do that? Yes? No? With me? Questions so far? Okay, so now what we're going to do, why don't you connect this point to that point, okay, with a segment, all right? So I'm going to take a segment, I'm going to connect this point to that point, okay, and click up. Got that? Yes? No? Maybe? No? Just connect this point to that point with your segment tool. Got it? Yes? Okay. Now, put a point somewhere to the right of this segment. So somewhere out here, about where you think. So take your point tool, okay, point, and just put a point somewhere out here, okay? And then you're going to construct a parallel through this point to that line. So you go to your parallel line tool, parallel line, and you're going to click on this and click on this, and then you should have a line that is parallel. Yes? No? Maybe? When you do that, after you do that, what I'd like you to do is put a point with your point tool right there at that intersection of that line and that one. Got it? We're there so far? Yes? No? Yes? Okay. Next thing you're going to do is hide those three lines. Okay? So watch what I do. You can do it all three at once. So you go here, you go Show Hide Object, and then I'm going to click on this, and click on this. And then when I click on my arrow tool, those all disappear. Yeah? See what I did? Now I'm going to connect those remaining points with my segment tool. So I'm going to connect this to here, okay? And this to here, and this to here. Okay, not to this point, because that's just a point on the line. And then if you click off this thing that you just create, what happened? What happened? Why is it?
You're supposed to go on the black dot, not the black.
Oh, it's supposed to go on this dot? Okay, now I have to go back. Undo. What did I do wrong? Edit, undo.
So instead of connecting it to
Oh, I got it. So going back, I'm going to connect this to here. That's right. This to here. And that should be a parallelogram. Okay? There we go. So now if I drag it, there you go. So this point is just the point that's controlling that bottom line. See that? Okay? So now go ahead. On page, go to page 281 in your book, okay? So go to page 281, and on page 281, there's a little investigation, okay? So I'd like you to, it says to use patty paper and graph paper, but I like this better. It's easier, it's more dynamic. You don't have to waste paper. Okay, so on page 281 in your book, there's an investigation. And I like you to go, it asks you to measure the angles. Then you're supposed to measure the, what are you supposed to do? You're supposed to measure the consecutive angles in the parallelogram, the opposite angles in the parallelogram. Then you're supposed to construct the diagonals and see if you can figure out some conjectures about those. So go ahead, do that little investigation for like 5 minutes, and then we'll talk about that. Okay? On page 281. Okay? Come on in. Okay, are you guys working on that? So, did you guys figure out that the opposite angles of your parallelogram are? The opposite angles of your parallelogram are the same, right? No matter how I drag that, those opposite angles, those opposite angles, those opposite angles that I'm dragging, this one and this one, stay the same. How about the consecutive angles, this and this? Those supplementary, right? So any pair of consecutive angles in a parallelogram are supplementary. And then if I were to drag in the diagonals, which is what you're supposed to, whoops, I don't want to do with that, okay? I want to do it for real, okay? So I'm going to do it for real. I'm going to do a segment, select 2 points. There we go. This to here, and this to here. And I'm going to put a point in the middle, right here. And then I'm going to measure the distance from here to here. So I'm going to go up here, and I'm going to measure distance or length. Okay, so I'm going to measure this distance from here to here, this distance from here to here. Isn't this cool? This distance from here to here. I love this. This distance from here to here. So now that we did that, okay, who can tell me something special about the diagonal? Let's drag, come on, drag, baby. There we go, drag we go. Who can tell me something special about the diagonals of my parallelogram? Go ahead. What's special? If this is equal to this, and this is equal to this, what is that said to do? What does that mean? If these two things are equal. All done?
Yeah.
How was it? Great. Okay. What can you say there? Hey, Trevor, what about the diagonals of my parallelogram? If this is equal to this, what does this do to that? Bisect, right? So the diagonals of a parallelogram bisect each other. Are the diagonals congruent? Are the diagonals congruent? No, they're not congruent. Do they cut in half the angles? I don't think they cut in half the angles. It doesn't bisect the angles like it does in a kite, right? See, this angle is not the same as that angle, but the diagonals always cut each other in half. So we're going to go over those last 4 conjectures that I have, C44 through C47. Parallel opposite angles conjectures. C44, the opposite angle conjecture, the opposite angles of a parallelogram are congruent. Good. The consecutive angles of a parallelogram are what? Supplementary. Okay. Supplementary. Oh, we didn't measure the opposite sides, but what's true about the opposite sides? They're congruent, okay? Opposite sides are congruent. Let's, do you believe me? Should I show you on GeoGebra? Yes, I should. Let's just show you. Watch. Distance length. This. Right? 9. This. 9. This. 17. This to here. 17. Look at that. Always, those sides are always congruent. 10, 18. Amazing, okay? But that's all based on properties of congruent triangles, which we'll get back to, okay? Going back, the diagonals, so congruent parallelogram diagonals, the diagonals of a parallelogram bisect each other, okay? Bisect each other. That's not always true for any quadrilateral. For a kite, right, only one diagonal was bisected, right? But for a parallelogram, both diagonals bisect each other. So that's kind of it for that set of conjectures. So now you should have these skills to do your next homework, which is page, what is it? I have it written down. Page 283. Page 283. You're almost done with that other one, right, Ian? Yeah, right. Okay. Page 283, 1 through 13 and 17. Okay? 1 through 13 and 17. So I'm not going to collect what you did on that investigation, that last one, but that's what we discovered. Okay? Got it? Questions? Easy enough?